Okay, welcome to Let's Get to the Marks, going through question 7. This question is about propanoic acid, CH3, CH2, COOH. This equation, the equation for the oxidation of propan-1-ol under reflux to form propanoic acid is shown. You can see we've got propan-1-ol. We've got an oxidation substance shown by the O in the brackets, and it forms propanoic acid. Notice that you always get a water molecule formed during this oxidation. Acidified potassium dichromate 6 is used as an oxidizing agent. State the color change in this reaction. Why don't you pause the video and have a go? Okay, I'm going to go through the answer. So potassium dichromate 6, the chromate ions are +6. Obviously, oxygen is -2. Times that by 7, you get -14. K, potassium is group 1, so +1, and that leaves you with 2 chromate ions that must be +6 to make 12 and cancel that out. Now, when it is oxidized and when you use it as an oxidizing agent, it's itself reduced. It gains electrons and it goes from green to orange. So your answer is green to orange. Okay, 7.2. A second organic product X is formed in small quantities. The boiling point of X is 49 degrees. That's quite a low boiling point. It's quite a volatile substance. This is something that evaporates easily. Identify X. Well, let's go up and look at what this small side product could be during this oxidation of propan-1-ol. So we're going to scroll up. And you look here, we got a primary alcohol. Why is this a primary alcohol? The OH group is attached to a carbon with 2 hydrogens attached. So this is a primary alcohol. And primary alcohols, when you oxidize them with potassium dichromate, if you're not refluxing, you're going to get an aldehyde. And then if you reflux, you're going to further oxidize them to a carboxylic acid. So we're looking at the oxidation to a carboxylic acid here. But of course, just because it's been under reflux, there will be very small quantities of the aldehyde. And which aldehyde will it be? Well, this is propan-1-ol, so it's propanol. And so we're going to get propan-1-al. Actually, no need to number it because aldehydes, the functional group always appears at the end of the molecule, unlike alcohols. So although you can get propan-1-ol or propan-2-ol, you can't get propan-2-al. You can only get propanal. Aldehydes, you don't need to number them. Their functional group only appears at the end of the chain. So the answer here is propanal. Now let's look at 7.3. Propanoic acid molecules cannot be separated from the reaction mixture by simple distillation because propanoic acid forms hydrogen bonds with water molecules. Complete the diagram to show how the propanoic acid molecule interacts with one water molecule through hydrogen bonding. Make sure you include in the diagram all the partial charges and lone pairs of electrons involved in this hydrogen bond, and this is worth 3 marks. So essentially we're getting a mark for showing the partial charges, a mark for the lone pairs, and a mark for the water molecule. And they just want one water molecule. So I'm going to draw my water molecule here, of course, OH2, so an O with 2 H's. Now I could bond from the hydrogen to the carboxylic acid, but I'm going to bond from the oxygen here. The hydrogen atoms will be delta positive. You don't really need to show that because they're not involved in the hydrogen bond with this one water molecule. But this delta negative oxygen is going to be involved. And it can't bond to the oxygen on the carbonyl group because that's also negative. They're going to repel. But it can bond to the hydrogen on the OH group on the alcohol because that's delta positive. So we're going to draw a dotted line to show that. And if I wanted, I could show another water molecule and I could do between the delta positive hydrogen and the delta negative O on the carbonyl group, or I could do between the delta negative O on the alcohol group there. But they asked for just one water molecule. So I'm going with the water molecule that's bonding to the OH on the carboxylic acid functional group. So I'm just going with this one. They specifically said one water molecule. Now, what have I missed out? I've missed out the lone pair of electrons. Now, there are 2 lone pairs of electrons on the oxygen molecule. And in the oxygen, in both the OH group and the carbonyl group, there are 2 lones. But it's only one of those lones I need to draw the dotted line to. So I don't really need both of those lone pairs. You could just do one lone pair. It's one lone pair that is forming the hydrogen bond with that delta positive hydrogen. There are 2 lone pairs on the oxygen. You only need to show one. I showed 2 just to show you, but there we go. An alternative method for preparing propanoic acid is shown. So I've got bromoethane here, which is a halogenoalkane. And if you react it with sodium cyanide under reflux in a suitable solvent, it's going to form, what have we got there? Propan nitrile. So name and outline the mechanism for this step 1. Name of the mechanism, let's go with that first of all. Well, if we look at the bromine atom, what's happened? It's been swapped with the nitrile group, with the CN. So what type of reaction do we call it when you swap something? That is a substitution reaction. Now, you can be forgiven if you made a mistake and thought it was addition, because notice it's gone from ethane to propane. It's gone, the chain has been extended, and extending the chain, people might think, oh, that's addition. But you've actually just swapped the Br for the Cn. So it's substitution. Now, what type of substitution? Well, the sodium cyanide is going to have a cyanide ion here, or a nitrile ion, whatever you want to call it, cyanide ion, and this is got a lone pair and a negative charge. Of course, that is going to be attracted to positive things like the delta positive carbon in the bromine carbon bond. So it's going to be nucleophilic. It's being attracted to the nucleophile, the delta positive carbon in that bond. So we call that nucleophilic substitution. Now we're going to get 2 more marks to outline the mechanism. So straight away, by the amount of marks, you know this is a simple mechanism. Nucleophilic substitution is a very simple AS level mechanism. It can come up in A2 chemistry as well. So what we're going to show here is the bromine carbon bond. Now, bromine is more electronegative than carbon, substantially more electronegative. So you're going to get delta negative on the bromine and delta positive on the carbon. That's going to mean that our nitrile ion, now I'm showing the 3 bonds here in the nitrile, you probably don't have to, you can just write Cn. You can put the negative charge anywhere on the nitrile, but that lone pair, draw the arrow from the lone pair to the delta positive carbon, and then show bromine can only have 1 bond, carbon can only have 4 bonds, so we have to break that other bond, and that's going to get you the 2 marks for those 2 curly arrows. Make sure you've got the lone pair and the negative sign. You don't need to show the product here because that's going to pick you up all the marks for the mechanism. 7.5 suggests one reason why water is not a suitable solvent for step 1. So what we want to look at here is, why is water not a suitable solvent? Let's zing up. Okay, think about water. What kind of ions do we find in water? Well, water is H2O. Water is made of hydroxide ions and hydrogen ions, so OH minus. What's going to happen if your OH minus from the water, which also has a lone pair and a negative charge, is going to attack that delta positive carbon in the carbon bromine bond? Well, you're going to get nucleophilic substitution, but this time you're going to get hydroxide ion swapping for the bromine instead. So you're going to form an alcohol, you're going to form ethanol. So suggest one reason why it's not a suitable solvent. You could say because ethanol will be formed instead, or hydroxide ions form an alcohol via a nucleophilic substitution reaction where the hydroxide ion is attracted to the delta positive carbon in the carbon bromine bond. So essentially you're going to get ethanol, you might get an alcohol side chain. So this is the reason we are going with superbulous. Okay.
You're still here? It's over.